All right, so we're moving on to this is probably coming from our 7-2 lesson, where we were learning how these angles can be, or how you can draw angles in coordinate planes. You can have angles greater than 90 degrees, greater than 360 degrees, and just kind of looking at angles in a different way. So what we have to do for these first three problems is to find the measure of each angle as a positive angle measure, a negative angle measure, and an angle measure that is greater than 360. So here's our coordinate plane. We have our x-axis and our y-axis. This is the initial side of every angle. Every angle that we draw in a coordinate plane will start here. A positive angle is going to go counterclockwise. It's going to go in this direction. A negative angle will start where they on the initial side where they start, and it would go down in this direction. And any angle that's greater than 360, that's a positive 360, so it would just go around more than one full rotation. That's how we get angles bigger than 360. All right, so first let's find the positive angle. So here's the initial side of our angle. The positive angle is going to go in this direction, and the angle that lands right here. This is the terminal side of the angle. So how can we figure out what that angle is? Well, this is 90, 180, 270. If we got all the way back to where we started, that would be 360, one full rotation. So I know that this angle measure is going to be between 270 and 360. They did tell us this angle measure right here. This is our reference angle, the 60 degrees. So the math that we can do is we can say, well, if we had gone a full rotation, 360, except we just didn't go that last 60, so we can say, all right, what's 360 minus the 60 to kind of get back to that terminal side, and we are getting a 300-degree angle. So this angle from here all the way around to here is 300 degrees. So there's a positive angle measure. Oops, I just erased some of that work. All right, so a negative angle measure, again, here's the initial side, is just going to go down to here. Well, I can see right here that this is a 60-degree angle, so we're just going down 60 degrees. So that would be a negative 60 degrees. The last thing they want is an angle that is greater than 360 degrees. So what we can do there is look at this angle right here that we figured out was 300 degrees. If we just go one more full rotation around from that angle, as long as we're landing on the terminal side of this angle, then we are finding an angle measure that's we're finding an angle measure that lands there that's greater than 360. So what we just did is we took our 300-degree angle and we went around one more rotation, so we just added 360 degrees to it. So that new angle greater than 360, 300 plus 360 is 660 degrees. So these are the three angles that will answer the question. It says find a positive angle measure, 300 degrees, a negative angle measure, negative 60, and an angle measure that's greater than 360, 660. Okay, now that we talked through some details on that, these next two will go a little bit faster. So let's figure out what our positive angle measure is. So here's the initial side. We're going all the way to here, which is the terminal side. We know that this angle is 60 degrees. So what we can think about is if we had gone all the way over to here, that would be 180. But let's take out that 60 degrees. So the math of that is just 180 minus 60 will get us the angle we're looking for. So this is a 120-degree angle. Um, Maybe we can find the one greater than 360 since we're on right here talking about this angle. If we have our 120-degree angle and then we just go around one more full rotation. So if we take our 120 degrees and we just add on a full rotation of 360, that's going to give us our angle measure that's greater than 360. So that's going to give us 480 degrees. And then the last thing that we're looking for is the negative angle measure. So if we start on our initial side, but we go down. So here's negative 90, negative 180, and then we have to go 60 more degrees. So negative 180 and another 60 degrees is a negative 240. All right, last one over here. We need a positive angle. So here's our initial side. Positive, we've got 90, 180, 270, and then it lands right there. Now, if we had gone all the way a full rotation, that would be 360, but we went 45 degrees shy of that. So the math we can do to find that angle is we can take our 360 and subtract the 45 degrees. That's going to get us 315 degrees. So our angle is 315 degrees. Now to get an angle that's greater than 360, we'll just go around one more rotation. So we can take our 315-degree angle and we can add on 360. That's going to get us to a 675-degree angle. So that's our angle that's greater than 360. And then last is we just need our negative angle. So our negative angle, if we just start on our terminal side and go down to there, we can see that's a 45-degree angle, but if we're going down, that is a negative 45-degree angle. All right, 9, 10, and 11 is just working on sketching the angles. So just getting practice with how these look. So when we sketch an angle, let's remember we have our initial side. It's always the positive side of the x-axis. 210 degrees is going to go up like this, and we're going to go around till we hit 210. So we've got, this will get us to 90, this will get us to 180, and 180 to 210 is another 30 degrees, so about a third of the way into the third quadrant. So here's 90, 180, I'd say right about there is where 210 degrees is. All right, negative 45 degrees. So our angle is going to start here with our initial side. And then because it's negative, it's going to go down. If we went all the way down to the next axis, that would be 90. So 45 is half of that. So this is just going to go down halfway into this quadrant. So there's our negative 45-degree angle. And then number 11 is in radians. So we have to sketch this out in radians. So what we do is we see that the angle is 5 pi over 6. We're actually going to ignore the 5 for a second and just look at the pi over 6. So in radians, an angle of pi goes all the way over to here, which is in degrees, 180 degrees. So 180 degrees and pi is the same angle measure. So if we look at this pi over 6, what we're doing is we're taking pi, which is the top half, and we're dividing it into 6 equal sections. Anytime that we're dividing it into an even number, this y-axis we can use as one of our dividing lines. if we were dividing pi into an odd number of sections, this line we would not use, and we just have to make sure we do a good job of ignoring it. So we're going to take pi and divide it into 6 equal sections, which means we will have 3 sections over here and 3 sections over here. So each of these is a pi over 6, pi over 6, pi over 6, pi over 6, and so on. And there's our 6 pi's over 6. So now our angle, the question we have to figure out is how many pi over 6's do we want? And that's what this top number is for. That tells us that we want 5 pi over 6's. So our angle starts with our initial side, like all angles do, and then we're just going to count. Here is 1 pi over 6, 2 pi over 6, 3 pi over 6, 4, 5 pi over 6 lands right there. I'm going to go ahead and make my angle really obvious because I have a lot of lines drawn on here. So I can see we have the initial side of our angle and the terminal side, and that's where 5 pi over 6 is. All right, so find the measure of an angle in standard position for each reference angle. So what we're going to do here is we are going to read the problem. This 10 degrees right here, we have a 10-degree reference angle in quadrant 2. So let's draw that out. Here's my coordinate plane. Just a reminder for your quadrants. The first quadrant is top right, and it always goes in the shape of a C. It goes 1, 2, 3, 4. So if you were to just draw a C through your quadrants, it starts at 1, goes around to 2, 3, and 4. I don't know who told me that at some point in my math career, probably when I was in high school or middle school, and I just have never forgotten that that's how I know what my quadrant numbers are. All right, so we have a 10-degree reference angle in quadrant 2. So a reference angle is going to be an angle that references the x-axis. So that means that we have an angle that is 10 degrees off of the x-axis, but in quadrant 2. So I'm going to go to quadrant 2, I'm going to go to the x-axis, and I'm going to go 10 degrees off of the x-axis. And I'm going to draw the angle. And this is 10 degrees right there. That is the reference angle. So we need to find the measure of the angle. So the angle has, in standard position, there's the initial side, and it's going all the way over to here. So what is this angle measure? Well, we know that if we had gone all the way to here, that would be 180 degrees. So we went just 10 degrees shy of that. So if we just take our 180 and subtract out that 10, we are getting a 170-degree angle. All right, next we have a 35-degree reference angle in quadrant 4. So let's draw it out. So we have quadrants 1, 2, 3, 4. So here's our fourth quadrant. And our reference angle goes off of the x-axis. So I'm going to go to the x-axis, I'm going to go down 35 degrees. And so that 35 degrees is between the angle we just drew and the x-axis. And now we need to just figure out what this angle measure is. So here's the initial side, and it's the angle that goes all the way around and lands right there. What is that angle measure? So we can say, all right, well, we went all the way around this far. Had we gone all the way back to here, that would be 360 degrees. But see how we're just 35 degrees shy of that? So if we take 360 and just subtract out the 35, that will get us to our angle measure. So 360 minus 35 is 325 degrees. So that's how big that angle is. All right, now we have a 34-degree reference angle in quadrant 3. So again, let's draw it out. We have quadrants 1, 2, 3. So it's going to go in this quadrant. It is 34 degrees off of the x-axis. So I go to the x-axis, I go 34 degrees into the third quadrant. So that's 34 degrees right there. Now our angle, here's the initial side. It goes all the way over here, 90, 180, and it goes another 34 degrees before it lands right here. So this is an example. We've done a lot with subtracting to find the angle, but this one we can see, oh, it's 180 and then even more. So we're going to add on 180 plus the 34 degrees. That's going to get us to our reference angle, or sorry, to our angle measure. All right, so 180 plus 34 is 214 degrees. All right, moving on to some conversions. Convert each angle into degrees. So when we convert between degrees and radians, so don't let radians throw you off. Radians is just another way, another unit of measure. You know, like you could measure in feet or you could measure in inches. We're measuring the same thing, just they just have different units. So if we have a radian measure, we could figure out, well, what is the same angle but in the unit of degrees? Or if we have an angle in degrees, we could figure out what is the same angle in radians. It's the exact same angle, just with a different unit. What we remember for converting our between the two units of angles is the fact that 180 degrees, so I'll just draw a quick little reference. 180 degrees right here is the same angle as pi in radians. So 180 and pi are the same angle measure. So we can use a conversion fraction with 180 and pi. So we have 180 over pi or pi over 180. We can multiply our angle by one of these two conversion fractions to get it into the other unit. I honestly don't have it like memorized. Oh, here's the one you use every time for this type of problem. I just think through which one will get me to the unit I need. So one key thing we have to notice is that our angles, when they are in radians, have a pi in the numerator. Here's a pi in the numerator. Our degree angles do not have a pi at all. So what we do is we take our radian angle, 3 pi over 2, and we have to multiply it by one of these fractions. We want the one that will make those pi's cancel out so that our degree measure no longer has pi in it. So the one that will make the pi cancel out is if we multiply it by the one that has the pi in the denominator, 180 over pi. Now if I just multiply these straight across, I'll show you what I'm talking about here. So 3 times 180 is 540, and then the pi over 2 times pi is 2 pi. So do you see how we have a pi in the numerator and a pi in the denominator? So those pi's do cancel each other out, and then just we'll take 540 and divide it by 2, and we get a 270-degree angle. No more pi in the angle measure at all. So 270 degrees. So anytime you have radians and you need to go into degrees, multiply by the conversion fraction that will cancel out the pi. All right, so this next one we have a negative 6 pi over 5. We want to get that into degrees, so let's multiply it by 180 over pi because we need a pi in the denominator if we want to cancel a pi in the numerator. Now you could cancel your pi's right here. We definitely have done some cross-reducing before. Over here, I just showed you, it's pretty clear to see why they cancel out when we do just multiply straight across. But you can cancel them here. And then we'll multiply negative 6 times 180. That's a negative 1,080. Divide that by 5. And we get a negative 216 degree angle. All right, now let's make sure, we went from radians to degrees. So how do we go from degrees into radians? So if we have 140 degrees and we want to get that into radians, so here's our 140, we want to multiply it by the conversion fraction that would give us a pi in the numerator because all of our radian angles have pi in the numerator. So we're going to multiply it by this one right here, times the pi over 180. So to multiply these, let's make this 140 a fraction so we can just multiply straight across. We have 140 pi over 180. So we got that pi in the numerator, so we're in radians now. And then we just have to reduce that 140 over 180. We don't want any decimal answers. Radian angles always have reduced fractions. So if we take 140 over 180 and reduce that fraction, we get 7 over 9. So it's going to be 7 pi over 9. All right, our next one we have negative 160 degrees. We need to multiply it by our conversion fraction that will give us a pi in the numerator to get us into radians. So that's pi over 180. Let's put this over 1, multiply straight across. You have negative 160 pi over 180. This is something we could reduce with a calculator. Sometimes, though, it's just nice to have little tricks up your sleeve. Anytime you guys are dividing two numbers that end in a 0, you can cross off the zeros. What we just did there is we divided those both by 10. So right away, we went from a negative 160 over negative 180 to negative 16 over 18. And now negative 16 over 18, we can just divide those both by 2, and we get a negative 8. The pi stays in the numerator, and then 18 divided by 2 is 9. So that is our angle in radians.